In this lesson, we're going to look at selecting a threshold value. Let's look at the threshold value t. The outcome of a logistic regression model is a probability. Recall that our regression model p for probability, we could say this is the probability of our result being 1. It is 1 over 1 plus e to the negative beta naught plus beta sub 1 times x sub 1 plus, and we keep adding terms until we get to our last variable, which is our last independent variable, and that would be beta sub n x sub n, given we have n independent variables. Often we make binary predictions, and that's what we're doing here, where our prediction is 1 for true or 0 for false. These predictions are made using the threshold value t. If p is greater than or equal to this threshold value t, then we predict a 1 or a true. If p is less than our threshold value t, then we predict a 0 or false. So what we need to do is determine what our threshold value will be. Let's consider our confusion matrix, otherwise known as a classification matrix. There are 4 possibilities that can occur based on our prediction and our actual values. If we predict a 0, then we are predicting a negative outcome. And if we predict this negative outcome when our actual is a negative outcome or an actual false, we say that we have a true negative. If we predict a negative and our actual is a true, then we have a false negative. If we predict a 1, we're predicting a positive result. And if we predict that positive result when the actual is 0, a false result, then we have a false positive. And if we predict a 1, which is a positive result, and the actual is true, it is positive, then we have a true positive. So here you can see that we have 1, 2, 3, 4 possible outcomes of our prediction versus our actual. So here we have 2 kinds of errors. We can have a false negative or a false positive. We need to consider these errors when we determine our threshold value t. If t is large, then we tend to have more errors that are a false negative. If t is smaller or small, then we are more likely to have more false positives. Since t represents a probability, then the values of t lie between and including 0 and 1. And if we have no preference as to whether we want to avoid a false negative or a false positive, then we could set t equal to 1/2 or 0.5. The true outcome measures are sensitivity and specificity. Sensitivity is equal to the value of the true positives divided by the sum of the true positives plus the false negatives. This measures the percentage of positives that we've classified correctly. This is also known as the true positive rate. Specificity is equal to the true negatives divided by the sum of the true negatives and the false positives. The specificity measures the percentage of negatives out of all the negatives that we classify correctly. This is also known as the true negative rate. A model with a threshold that is high will have a lower sensitivity and a higher specificity. A model where the t-value is lower will have a higher sensitivity and a lower specificity.